Hey, Vlad here, devinsidey.com, and welcome to the next video in the Scala playlist. You might have not realized, but we're actually in the middle of a micro playlist that is inside of the longer playlist for Scala. This micro playlist is about general knowledge for programmers. These are the small things that you're likely to use on a daily basis, like for example how to create objects out of thin air, as we've seen in the previous video about literals, or how to convert them from one type to another, or how to combine them together and to create yet another object. There's an infinite amount of patterns like this, and even though I tried to keep this video short, I failed as always, so I might end up splitting it in 2 or maybe even 3. We'll see. Let's get started. As always, we're inside of the virtual machine, which runs Ubuntu, in this case Ubuntu 16, and we have Sublime on the left and SPT on the right that runs our code. We're going to start with simple widening for numbers. So we're just going to have a bunch of vowels, and we're going to print them out. So we're going to have while A, which is a byte, 1, we're going to have a B, which is a short, and we're going to assign byte to the short, right? So it's going to get, so the byte is going to get widened to the short, and we're just going to keep going with this. So we're going to have vowel C, which is an integer, it gets to B assigned. We're going to have a D, which is a long, and it gets the C assigned. And a bit later, we're going to have a float, which gets a D assigned, and we're going to have a double, which gets an E assigned, right? And we're just going to print them out. So we have 6 of them. So let me have a print line 2, 3, 4, 5, 6, and let me just copy them and let me just paste them. Oh, that's a D, of course, right? So there we go. So as a reminder, what we have over here is, God damn it, we got 1 bytes, which is 8 bits, right? Over here we got 2 bytes, which is 16 bits, and over here we have 4. Why am I doing the capitalization all of a sudden? Which is 32 bits. And over here we have 8. Let me remove the cursor, which is 64, right? And for the floats, we have the same relationship. So let me actually just copy that. So float is like an integer, and a double is like a long. I'm not going to go into detail with this, but this confuses a lot of beginners, especially this line. Okay, sorry, not this line. So we have a D, right, which is a long, which is 8 bytes long, right? And over here we're taking it and we're assigning it to an E, which is a float, which is only 4 bytes long. How does it work? Widening is designed in such a way that you don't lose information, and in order to demonstrate that, let us have just 2 numbers. So we're going to have a max long, which is long dot max value, and let's actually specify the type just to be sure that it's a long, right? And now we're going to have a some float, right, which is a float, and it's going to get max long, right? So the first that we're going to do is we're gonna just print out with a space in front of it, because I know how it's going to look like. We're going to print out the max long, okay? And let's see. So this is how a max long looks like, and there's a space over here in front of it. Okay, so the next thing that we're going to do is we're going to print out a float, right? Some float, and we're going to see that it looks very similar. And let me actually finish the table real quick. So we're going to do the same thing for float that is converted back to long, right? And over here we're also going to compare them, right? So we're going to compare the max long to some float that is converted to long, and those spaces are necessary so that they can look like a table, so that you can see that that it's actually the same number. So we're converting it back and forth, and we're actually getting the same number. So it works in such a way that a float, even though it's 4 bytes, somehow it manages to not to lose the magnitude from long. Right, so somehow these 8 bytes are stored in a representation that fits into 4 bytes. In fact, I'm not actually sure. It might actually fit into less than 4 bytes, and so you will actually lose precision if you're converting from floats to long and from longs to float, but you will never lose magnitude. We're not going to go into details of how it is actually stored. What we're going to do instead is we're going to comment out those print lines, and we're going to show you how a number like 5,000,123,456, how it's printed out as a double, right? And we also know that there is a scientific notation for doubles, right? So if we have 5e and there are 6 zeros, right? If we print it out like this, it's the same number, but if you look at it, we used only 3 characters to represent it, and a similar technique is happening with a binary representation of longs and floats, right? Not longs, just the floats. Okay, so somehow 8 bytes, because they're represented differently, they will fit into 4 bytes and probably even less. And by the way, since we're already talking about numbers, let's see what's going to happen if we actually have one more zero. So we have one more zero over here, then over here, right? Hold up. Let me have a 7, but let me not print it out. So if we have one more zero, right? So we have 7 zeros, then this is how doubles are converted into strings. This is how they're represented. They're represented exactly in the scientific notation. So this is sort of like a hint that this is actually what's happening there. By the way, floats and doubles, they're stored in the same way, just so the double has more precision bits. This was a tiny excursion into how longs are stored with floats. Let's actually go back to the widening, right, that we had in the very beginning, like that. And let me actually remove the things on the right. Okay, so what we're going to do now is we're going to do the widening for characters, right? So we can start with bytes, right? So we're gonna say that this is not a short anymore, this is a character, and we're just going to put the single quotes around it, and this is going to become a character. And obviously we can't print A anymore because A doesn't exist. So there's nothing spectacular here. We already discussed this in the previous video. Characters are represented as numbers. It's just a table where they're getting looked up. So an a small a happens to be 97, and when it reaches the float, then it becomes a floating point number. And by the way, so the A is 97 and the capital A is 65. Now let me press Ctrl Z a few times and actually go back to the original widening, the one without the chars, right? So to this one. So what we're gonna do now is we're gonna do the opposite of widening. We're gonna take the bigger type and we're gonna convert it to a smaller type. And because there is a chance that we're gonna lose something, Scala is not gonna do this for us. So we have to do it ourselves. So because we're going from top to bottom, we're actually going to have a B here, and we're going to start over here with a 1, right? So over here, we're going to say F dot to float, and over here, we're going to say E dot to long, and over here, it's going to be D dot to int, and over here, it's going to be C dot to short, and over here, it's going to be B dot to byte. There we go. And because it's all vowels and we're accessing a B before we actually declare it, we have to change them to defs, right? So if I'm going to compile it right now, it's going to say, hey, you're using it too early. So we're just going to turn this into defs because in our example, it doesn't really matter. Before we continue, let me actually switch the order of print lines. So I want to have F first and an E, D, C, B, and then an A. Okay, and what I also want to have is I want to have the types, right? So I'm just gonna go select the columns, I'm gonna select the types, right? And then I'm gonna put my cursor over here, and I'm gonna create a string with this thing and with a tab and with a plus, and this is how it's gonna look like. Which is of course wrong because I copied them top to bottom. This is a double, this is a float, this is a long, this is an int, and this is a short, and this is a byte. And there we go. So now it actually makes sense. So I just said that we're actually losing precision if we're taking something that's not going to fit. So let's actually take something that's not going to fit. So let's take double dot max value and let's see what happens. Whoa, okay, so the double max value is this, right? And it doesn't fit into a float, and therefore we're seeing this infinity thing. This is the thing that we're gonna play around with in the next few seconds. And then we have our long. You might not see what's happening here, but this number is actually exactly the same as this one. Well, not exactly the same, but it's the same magnitude. So the thing about doubles and float is that they have exactly the same amount of space, exactly the same amount of bits to represent the magnitude. However, the double, it has way more space to represent the precision, right? So the double can be way more precise, but it can't display a bigger number in terms of magnitude, right? So if we actually demonstrate that, so if we actually have a print line long dot max value. If it's the same as double dot max value converted to a long, we should see a true over here, right? So it's exactly the same number. So let me remove that again real quick. Okay, so over here we have overflows. Remember we discussed overflows in the previous video. The next thing that we're going to talk about are those so-called magic numbers, right? So this max value is a magic number, and there are quite a few of them. And let me actually remove everything from here, and let me copy a table that I have already prepared from over here. So I'm just going to run it, and it's going to display exactly which kind of code you have to type in so that you would get this answer, right? So if you use the float dot negative infinity, which is exactly what you see over here, you're going to get this. If you got min value, you're going to get this. If you got min positive value, you're going to get this. If you're going to get min value from Java, it is actually not going to equal min value from Scala, and therefore this is exactly why Scala has another magic number for exactly the same thing as in Java. It's called min positive value. So these two are the same, but Scala's min value is not the same as Java's min value, right? And then you got your the same thing for the maxes, right? So you got max values are the same. There's positive infinity, obviously, and then there's this weird thing called not a number. So before we continue, I'm going to do the same thing for floats, right? So if I'm just going to print it out over here, let me actually maximize Sublime. So all I need to do is I need to copy this, paste it over here, and then mark everything that says float, right? And just replace it with double, and we're going to have exactly the same magic numbers for double. Right, it's just that the values are sometimes a bit different. Now let's play with magic numbers for a bit. So first of all, let me print out a 0 divided by 0, and let's see what's going to happen. So what's going to happen is this Java long arithmetic exception. Let me copy that. And I'm just going to put it over here so that we know what's going to happen, right? And actually, let me do this, and let me do that. All right. So we got our arithmetic exception. So let's try the same with 1 divided by 0. Well, it says, hey, I just told you dividing by 0 is not cool, right? So let's do this similar thing. Let's just copy it over here. And I'm showing you this because as soon as we're in the realm of floating point numbers, right? So if this 0 that we're dividing by is all of a sudden a float, right? Then what we're getting is not a number, right? So that guy is not a number. And if we're going to try to do the same thing with a 1, right? So if we have a 1 over here, whoops, sorry. All right, so if we have a 1 over here, then we have infinity, right? So this thing is an infinity. And the same thing is going to happen for doubles, right? So if I copy this, I have an empty line over here, paste it over here. So if these are doubles, the same thing is going to happen. These are just one of those things that you need to know, which is what this video is about, right? The daily things that you need to know. All right, so since we already arrived by arithmetic, let's actually do some basic stuff. So we're gonna have print line 3 plus 5, and we're gonna just copy that a few times, and we're gonna have a minus over here, and we're gonna have a times and divide it, and this is going to be modulo, which is the rest division. We're actually going to dedicate quite some time for this in this video, right? So nothing surprising is coming out of here. Maybe the modulus one, but again, we're going to dedicate a few seconds for a few actually minutes for it, because I realized that this is a thing that is very well known by programmers, but in high school usually you don't talk much about digital things. There's also nothing about cryptography or something, right? Because in cryptography this is used quite often, right? This is why I'm gonna spend quite a few minutes talking just about this. Before we continue, this probably deserves its own video, but this is just a syntax for a method called plus, which is defined on an integer, right? And it just takes 5 as an argument. So this is just the same as saying call this method on the 3, right? With this dot notation, right? And then pass in 5 as an argument. We're gonna as of right now we're using symbols over here, but very soon we're gonna also use words, and then this explanation should help a little bit. But again, this we didn't arrive yet in this playlist to the place where we can talk about object orientation and what does it actually even mean to define this method inside of this type, because we don't even know how to create our own types yet, right? But we're gonna get there. So let me comment this out and let's play with division a little. So let's have an empty line over here, and let's duplicate this one, right? And then we're going to have the same thing was, I don't know, was 4, 5, and 6. Actually, we don't really need this anymore. Let's just remove that. So we just have division: 3 divided by 5, 4 divided by 5, and 6 divided by 5. Now this is not the same thing as coming out as what you're used to that is coming out in math, right? Because over here, what is coming out is an integer, right? So what we have here is an integer division, right? So we say, how many times does a 5 fit into a 3? Well, 0 times. How many times does a 5 fit into a 4? Well, 0 times. How many times does a 5 fit into a 5? Well, okay, actually 1 time. How many times does a 5 fit into 6? Well, actually still 1 time, right? So we have some rest, and this is what the rest division is for. In fact, let me do exactly the same example over here. I'm going to copy that, paste it over here, right? And we're just going to replace this with that. Okay, and this is how much is left, right? So it's not how much is left to the next 5, right? It's just how much is left after we kept dividing it like this, after we kept fitting the entire 5 into the number on the left. So as I already mentioned, what we're going to do now is we're just going to play with this so that you understand a little bit more what this actually is. So let me remove this, and let me have more examples of this. So we're going to have a 2, a 1, and a 0. Okay, and we're just going to keep going like this until 10. So we're going to have 7, 8, 9, 10. Right. So this is going to be a 7. It's going to be an 8. It's going to be a 9. This is going to be a 10. And let me actually have a space over here like this. Okay, like that. And actually maybe go back to this, to having Sublime on the left and the terminal on the right. Okay, so let me save again. Okay, so this is what we have. So the 5 fits entirely into a 0, right? And over here, a 5, it does not fit entirely into a 1, right? It fits entirely into a 0. So what's left is a 1. This is why we see this 1. Same thing over here. What's left is a 2. What's left is a 3. What's left is a 4. Now, all of a sudden, the entire 5 fits in, right? So what's left is a 0 again. Over here, 5 fits entirely into a 6. But what's left? Well, what's left is a 1. 5 fits entirely into a 7. But what's left? It's a 2, right? So we kind of have this cycle, right? So which repeats every 5 basically, right? So this is 0, this is a 0, and this is a 0. In fact, what we're going to do as next, we're going to have a bit of a mathematical way of writing this down, right? So this is just a 0, right? So we're going to do the first one, right? So this is just a notation for what we're writing over here. So this is a 0 minus something, right? And this something is going to be 0 divided by 5, right? So this is what we had. How many times is it actually going to fit, right? And multiplied was a 5, right? So this thing, we're subtracting this thing from a 0, right? And what should come out is a 0. Let's actually have a print line over here, and let's do the same thing for a 1, right? So there's going to be a 1, and this is going to be a 1, right? This should look exactly the same, right? Exactly the same as at the top. In fact, let me copy paste it from what I already prepared, and it's going to look exactly the same, right? So it's going to look over here, right? So just look at this a little bit, and this is exactly the same thing. This is exactly what's happening. This is just built into the language. Now, if we're actually going to get lower, right? So if we go to -1, right, and you might suspect that it's just going to work out. Well, actually, it's not, right? Because what you get all of a sudden is -1 and -2. Usually, this is not what you want, because usually you want this sort of cycle, and we're going to have more examples for this in a second, right? So the same thing is going to happen over here, right? So if we have a -1 over here, right, and we have a -1 over here, right, and we have the same thing with a 2. Exactly the same thing should come out, right? Over here, it's exactly the same thing. But there's a trick. As you can see, there is this cycle, right? There's this repetition. So it doesn't really matter. For example, if we're over here, the 6 modulo 5 is exactly the same as 1 modulo 5, right? So it doesn't matter at which cycle we currently are, right? So what we can do is we can just imitate this cycle. So let me remove everything except for the negative examples, right? So these two examples, they give us -2 and -1. So let's just pretend like we're in the next cycle, right? So instead of let me just copy that actually. So instead of having just this, we're actually gonna pretend like we're in the next cycle. So we're just gonna add a 5 over here, right? And the same thing with a -1. Now we actually have our cycle back, right? So if the next number is 0, right? So 0 divided by 5 and let's just have 1 and also a 2, right? So now we have our cycle back. We have 3, 4, 0, and then again 1, 2, because it's exactly the same thing as over here, right? So it doesn't matter which cycle we're on, right? So let me do this over here, plus 5, and over here, whoops, 2 plus 5. That's a plus. Jesus. Okay, right. So so this is exactly the same thing, but it shouldn't matter on which cycle we're on, right? So we could add 5, we could add 10, right? We could add 15, we could add 20. It doesn't really matter. There are quite a lot of use cases for this. By the way, this is called rest division, or modulo, or sometimes modulus, I believe, modulus, right? But usually modulo is used. Okay, so it's quite common to have something like this. That is, even some number comes in, a boolean comes out, and it should be equal x modulo 2 equals 0, right? And you can have the same thing for is odd, right? And then you can have this. You can say it's not equal to 0, or you could actually define it in terms of is even. So it's not even, right? It should be exactly the same thing, right? So let's have an example. So let's have a tiny loop that goes from 0 to 10, right? And we're just gonna have an e plus plus over here, which does not work in Scala, but I'm still kind of used to writing it. Sorry, e plus equals 1, right? And we're gonna have here is just print line is even of I, right? It's going to be true, false, true, false, true, false. So what we're now going to do is, well, if it's even, right, only then print line, right? So we have some sort of like a filter, right? So now we're only printing out the even ones, and now we're printing out the odd ones. We're going to keep playing with rest division for a bit, but before let me comment this all out, right? Because I'm tired of writing loops like this. So let me introduce you to this thing. So remember we did 1 plus 2, right? And I said that we keep using symbols, but eventually we're gonna use something else. So the something else is going to be 2. So right. So let's have 1 to 10, and what is being created is a range from 1 to 10, and you can also have a range 1 until 10. It's going to be 1 until basically it's going to go from 1 to 9, right? But let me actually write it like this, right? So the type of it is range, and I believe so you can say range, right? I'm not sure if it's going to compile like this. Maybe I need braces. No, it's fine. And it's actually a raise. So this one is range inclusive, I believe. Yes. So why am I showing this to you? Because I actually want to start replacing these while loops that I'm using for demonstration purposes with those ranges, right? So what I can do is I can now say 1 to 10, right? And I can say for each, which is a method that is defined on the range, right? And this gets a functional literal, right? So whatever comes in, all I want to do with it is I just want to print it out, right? So now all of a sudden I sort of have a loop that goes from 1 to 10, okay? It actually kind of reads better, and for this very specific case, actually we could use ETA extension, right? So we can just say 1 to 10 for each print line, right? Because print line has basically the same signature as this functional literal. Let me comment these out for a second, right? So let's do the same thing with 1 until 11. Should look exactly the same. Hold up. I just want to have an empty line between them every time, right? So 1 to 10, 1 to 10, but this is actually has an 11 over here. You can actually have the same thing with characters, right? So you can have A to Z for each print line, and we're going to have an empty line, right? So we have A to Z, and over here, we're going to have the same thing, but with capital ones, right? So we're going to have A to Z. In this table that represents letters, all the letters, they just happen to come right one after another. So 65 is an A, and 66 is a B, and 67 is a C, and so on. In fact, you can actually do some arithmetic. Let me comment this out a bit, right? So what you can do is let's print out an A, right? And then let's print out an A plus 1, right? It's going to be A and 66, but if you convert this back to a char, and I'm actually not sure if I can do a type ascription over here, probably not. Oh yeah, I actually can, right? So if I'm telling it to use it as a char, then it's going to convert, and then it's going to be a B, right? And this is exactly how this range is working. All right, so let's remove those ranges. because I only introduced them just so that I can do this again, right? So this while loop, it just goes from 0 to 10, right? So let's have this. Let's have 0 to 10, and then for each, and then we have an I, right? And we're just gonna copy this, right? And that's it. We don't need to increment the I, right? Because the range is doing this for us. This for each method, it knows how to go through the range, right? So it's exactly the same code now, right? So let's have it one time like this, right? And let's have it one time like that, right? So now you're convinced that it's exactly the same thing. Let's remove that. Let's have that. So you see the full example, right? So this is odd, and this is even, right? It works. Okay, let's finish this discussion about modulo. In fact, I'm realizing right now that I probably should have created like a completely separate video just about this topic alone, right? Anyway, so this modulo, you use it when you have cycles, and you have natural cycles every time you're talking about time, or you're talking about something finite like memory, for example, or you're talking about an angle. So let's actually do those examples, right? So when I'm gonna have this, we're just gonna have that, right? And we're gonna remove these. Right, so what we're gonna have seconds in a minute, right? And it's gonna be 60. And what we're gonna do now is we're gonna pretend like we're like sort of in the end of the minute, right? So we're just gonna be 5, right? And we're gonna go to 70, for example, right? And we're not gonna print out the I, right? We're gonna print out I modulo seconds in a minute, right? So the seconds in a minute, they go like this, right? They go 50, and then they go 58, 59, and then they go back to 0, right? They don't go back to, they don't go to 60 and 61, right? This is the perfect example for modulo. So just to explain this again, you have a sort of like an infinite stream of numbers, right? But you're making sure that they all fit into this finite cycle, right? So let's do 1 until, I don't know, 100. Does it make sense? 1 to 100. Yeah, so we're going to start with 1, and then once it reaches 59, it's going to go back to 0, and then it's going to go to 40, right? So this is all the 100 numbers, right? And the next example that we're going to have is, let's say that this is degrees in a circle. Does it make sense? Degrees in a circle, and they happen to be 360, right? Let's do here 350 to 370, right? And that's exactly what you want to have with your angles, right? They go to 359 and they go back to 0. We could also do one more. We could do hours in a day. We're gonna have 24, right? And let's go from 0 to 48, right? So we know 48 hours is 2 days. So we go from 0 to 23, and then we go back to 0, and then we go back to 23, and then we have 0. All right, we're done with modulos, and the next thing that we're going to do is a simple comparison operators. So we're going to have our favorite 3 and 5, and we're going to have 3 smaller than 5, or actually it's pronounced less than 5, right? So we have less than equals, then we're going to have equals. This is equals, by the way. If you're coming from Java, this is actual. This is actual equals. This is not referential equals. This is not equals, and this is greater than equals, and this is greater. All right, for these guys, common sense actually also works. So let me do this and this. So if this is, for example, a double, then it doesn't matter. It's still gonna work, right? So 3 is still smaller than 5. It doesn't matter that it's a floating point number. So you have a bunch of other operations. In fact, you have like a whole library. Let me actually do this. Let me do 1 to 12 for each I, right? Let me print out I plus a tab character, right? Plus, so you have scala.math, right? And it has a bunch of useful mathematical functions or methods. I'm gonna leave a link in the description where you can see all of them. So this is, for example, power. So it's gonna take a 2 to the power of all of these i's, right? So it's gonna be 2 to the power of 1. Actually, let me start with a 0. Let me start. Okay, so 2 to the power of 0, then 2 to the power of 1, 2 to the power of 2, and so on and so on and so on. And it returns a double, so let me actually convert it back to an integer, right? So it's going to do this now, right? So what we see here is powers of 2. There are other useful operations like, for example, min. So it's going to take the smaller one, right? So it doesn't matter on which side it is. It's always going to take the small one, and you're going to have the same thing for max. Max right? And you have many others. Actually, let me do one more. So this is how you create random numbers. So let's just have a function called random, and it gets a maximum, right? And we're just going to forward it to a Scala util.random.nextInt, which expects this maximum, right? So if we just call it a few times, random, let's say generate a few numbers until 10, right? So it should do this, right? So just completely random numbers. So it goes until 9. Actually, it's never going to generate a 10. It doesn't matter how often we have this, it's going to go always from 0 to 9, right? So we're never going to have a 10. Actually, I'm going to try to avoid doing this from now on, because now we have this useful syntax. So 1 to 10 for each I, we're just going to print out a random it's not going to be an I, it's going to be a 10. So we want to have a 10 here, because we actually don't care about I, and as always, if we don't care about an I, we just have an underscore here, right? So we're just telling it to generate a number from 0 to 9 10 times, right? Let's do this, I don't know, 20 times. One thing that you should know about random numbers in computers is that they're not actually real random numbers, right? So they use just a very fancy mathematical function, which was a crazy distribution, right? So that it creates like a completely different numbers every time, right? But you actually can sort of foresee what the result is going to be. So you can, because it's just calculated, right? So this is just one of those things that you know. So they're called pseudo random, right? Not actually random, and but it doesn't matter. So let's say we know already how to generate random integers. But how do you generate, for example, random Boolean? I'm not actually sure if it exists in the Scala library, but it's super easy to define it yourself, right? So what you do is you generate a number between 0 and 1, right? So let me not have this anymore, right? Actually, let's just remove it, okay? So we're gonna have a function called random 0 or 1, okay? And it's just gonna give you an integer, right? So all it's gonna do is just gonna call random was a 2, and now we're gonna have a function called random Boolean, right? Boolean, which is going to give us a Boolean, right? And all it's going to do is it's just going to say, okay, so if random 2, if it's a 1, then just give us a true, and otherwise return us a false. And by the way, this is a common thing that beginners like to do, but if you look at it closer, you already have a Boolean over here, right? So you say if this is true, then return true. If this is false, return false. So basically, the better way to write this is going to be, let me copy that. I'm going to have a 2 here. The better way to write this is just to leave this expression alone, right? So this expression is already a Boolean, right? So this is exactly the same thing, right? Look at it, and now it's gone, right? Okay, so now we have those 3 functions, but we're not doing anything with them. So let's actually do something with them. So let's just say 1 to 10 for each, and in this case we don't care about the I, and we're just gonna say line random Boolean. Speaking about Booleans, let's do some Booleans. All right, so we're gonna have a literals first. So we have a true and a false, right? They are sort of obvious. And what we have here are typical operations on Booleans are, so negation, right? So this is not true, so it's a false, right? And over here, we're gonna have a not false, which is a not false, which is a true, right? So if we print them out, we're going to have true, false, false, true, true, false, false, true. The next thing that we're going to have is and. So we're going to have a print line, and we're going to have true, and true, and true, and true. So if all of them are true, that it actually is going to remain true, right? However, if one of them is false, even if it's the last one, it doesn't really matter, then the whole expression is going to be false. Another thing that you need to know is that there's an optimization built in, so it's called short circuiting, right? So if the first one, right, so let's copy this one, right? So if the first one is already false, then there is no need to evaluate this expression, right? And actually, this whole expression is not going to be evaluated. So if you're just going to say invisible, right, semicolon, and the rest of the expression, then we're actually not going to see invisible. Of course, I did it wrong. This and symbol should be here, right? So we say false and this whole expression, the one that starts with the print line, right? So we don't see the print line because it saw that the whole expression is going to be false anyway, right? So there's no point in going further, right? And the next one that we're going to have is or. Let me actually maximize Sublime. Next one is going to be or, and it's going to be pretty much the opposite, right? So let me actually copy this, right? And let me replace every true with a false, right? And let me replace these things with pipes, right? So this is an or. Let me minimize it again, right? So it's sort of like a mirror, right? So if all of them are false it's going to be false. Whereas over here, if all of them were true, it's going to be true, right? It's like a mirror, right? And then we're going to have the same thing as over here, right? So if you just sort of flip them, right? So if this false, 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 as soon as one of them is true, right? As soon as one of them is true, come on, what's happening? Why don't you like them? There we go, right? So as soon as one of them is true, then the whole expression becomes true, right? So the last one is now true, right? And it also shortcuts exactly in the same way, right? So let me duplicate this line. Let me just literally flip everything. So this one is a true. These guys are ors, right? Do I have them? Yeah, I have all of them, right? And these guys are false, right? So as soon as the first one is already true, there is no need to evaluate all the others, right? Because the whole expression is already going to be true. And I'm going to maximize it so that you can look at it. And by the way, I'm going to have all of it in on GitHub, right? And you will always have a link down in the description. And if I sometimes forget to put the links, then you can always find my links at provider or service.devinsider.com, right? So for GitHub, it's going to be github.devinsider.com. For Discord, it's going to be discord.devinsider.com, and so on. So let me minimize it again, and the next thing we're going to do is strings. Remove that, remove that. All right, so let's have a hello world first, right? So typical operations on strings are contains world, and it's true. Contains hi, it's false. So what you need to know is that strings are 0 based, right? Which means the first character has an index of 0, right? So this means that if we do a print line hello world, and there is an operation that says substring, it's called substring, right? And you give it a 1, and the 1 means from the second to last character, because if the first character is 0, then index of 1 is the second character, right? Let me actually maximize this so that it makes sense. The first character has an index of 0, so the index of 1 is the second character, right? And it's going to go from the second character to the last character, so basically it's going to do this, and it's going to create this string, right? So what we should see is hello world, right? So let me save, and we're going to see hello world. You can actually have 2 parameters, right? So let's say start with a 0, but only go until 5, right? And what that's going to do is it's going to start with the first character, right? Because remember, they're 0 based, right? And it's going to go to the 5th character, right? So unfortunately, it's inclusive, right? I know this is confusing because the indexes are actually going from 0 to 4, right? So 0, 1, 2, 3, 4 is 5 characters, right? So it goes from the first character to the 5th character, but for the index, because it's 0 based, it goes from 0 to 4, right? But what you're actually specifying here is 0 and 5, unfortunately, right? So it goes from the first character to the 5th character. Maybe it's going to be more clear if I do a 4 here, then it's actually going to remove the O, so it's just going to be HELL. Right, but yeah, I find this API sort of confusing. Like for years, I'm constantly looking it up. I'm playing with it every time before I actually use it, if I use it these days. The next one is reverse. So let's print out. Actually, let me do this again. It's gonna make more sense, right? So let's do hello world dot reverse. The next thing we're gonna do is we're gonna replace the L with a 1, and it's going to be really confusing. And the 1 obviously has to be a string as well, right? So now it's going to look HE110 war 1D. There's also a function called replace all, right, which sort of does the same thing, but the argument that it's actually accepting is a so-called regex, and the regexes are a very big topic for another video, right? So what you can do is, instead of what you're not giving it is what you're giving it is not a string. What you're giving it is a special syntax for forming a pattern for strings, right? So for example, you can say take the L, the first L that you find, right, and then everything after it, right, and replace it with 1s. I'm sorry, I said it wrong. So it says find the first L, and then take this L and everything that is coming after the L, right, and then replace what is currently marked with a 1. So this is what it's doing, HE1. But again, as I already said, regexes are a very big topic. They're a topic for another video. So the function replace is coming from Java, and it actually collides with some API from Scala. And therefore there's a function called replace all, literally, which is doing exactly the same thing as replace, right? So this takes a string, this one takes a string, and this one takes a regex. Why did I do the X like capital, right? So there we go. Let's do this so that it just looks beautiful. There we go. Takes a string, regex. Okay, so that's enough for one string, or actually for one screen. Let's actually start combining them, right? So what we're gonna do here is this one that you already know kind of from the hyphens, right? So a multiplied with a 3 is the same as over here, 50. So 3 a's, 50 hyphens, right? We already sort of know that, right? So, and we've already seen a bunch of times where I do something like hello plus, and then 0, and then a plus, and then a world, right? And mathematicians, by the way, don't like it that when they come to programming, they don't like the fact that we're using plus, because the sum in math, it has very strict rules. Like, for example, it's actually commutative, but hello world is not the same as world plus hello. I'm sorry, hello plus world is not the same as world plus hello, right? Whereas a 1 plus 2 is the same as 2 plus 1. So this obviously works not only for strings. So if we have, for example, a favorite number, right, which is an integer, which is a 1337, okay, and if we just want to print out, let me print it out over here, right? So let's say we want to formulate a sentence. So you want to say my favorite number is colon equals plus, and then you have your favorite number, right? And then you have another plus, and then you have another and then you have another dot over here, right? So this is my favorite number, right? And in Scala, sort of unfortunately, many people don't like it. You can actually start it was a type that is not a string, right? So this is an integer, right? But we can actually say plus, and then it will automatically get converted to a string over here, right? So I'm gonna write it once like this and once without the toString, right? So what we're gonna say is, so this is my favorite number, right? And it's gonna be the same as that, right? Sorry, to a string, right? There we go. So please prefer this and not this, because this actually sometimes leads to bugs, right? So in this case, it's literally the same thing, but many times it actually leads to bugs. So sometimes you actually want to add some two numbers together, but all of a sudden you actually had a string, but you didn't notice, and then you see only in production because it compiles. There's also a function called format, which is defined on a string, right? So you can say my favorite number is, right? Let's actually have a space here. So my favorite number, so like over here, right? And then we're gonna have a space, and we're gonna have some weird syntax here. We're gonna have the percentage symbol and then an s, right? Which is gonna denote that we're gonna give it a string, right? And then we're gonna do format, and only then we're gonna pass it the favorite number, right? So it's gonna look like this. And actually we want to have a dot over here, right? Because this is a sentence, right? All right, so we have a dot, right? And there's actually a built-in thing for this that sort of comes back from the old C types. So instead of saying print line and then call format on string, we can just do printf and then do the line ending ourselves, right? And then instead of saying format, we're just going to pass in a second argument to printf, right? So it's going to be exactly the same thing. So again, we have a print line where we're just giving it a string with some special symbols, and then we're calling format on that string, and we're passing it what should be formatted, right? And in this case, it's the same thing, but it's like printed out and formatting of the string at once, right? So we're using a printf, which is not going to include the new line character, right? So we have to introduce it ourselves. So you can also say and some other number, right? So we're gonna do 3771. So you just can keep going with arguments like this. But let me revert this. There we go. Now these two ways are sort of old. There's a much better way these days, and it's called string interpolation, right? So you start it with a letter S, and only then you have the string, right? And then you do exactly the same thing as over here, right? But then instead of having this weird syntax and then calling dot format, all you do is you just say dollar, and then you use your variable. It's actually supported by the syntax highlighting. Let's actually do this variant as well. So let's have it over here and then start it like this, dollar, and we don't need to concatenate anything anymore. So I believe I did it right. So one thing that you need to know about this, that as soon as you forget an S, it's not going to know that it should interpolate it, right? So it's literally going to print out this. It's going to literally print out dollar favorite number, right? Because as of right now, it can distinguish it. But you sort of get a hint from the syntax highlighting, right? There we go. One thing you need to know is that the syntax over here only works for simple expressions. So if you have actually a completely different object over here, let's call it far away, and we're going to have a val favorite number again, favorite number, right? Let's say in this case it's 3771, right? So let's say you wanted to do these two things again, right? Let's have them over here. So let's say you wanted to do far away dot over here. See, the syntax highlighting is already broken, right? So so you can't do this, right? What you can do is though, see, it looked weird now. So what you can do though is you can have a scope around it, as always. When in doubt, have another scope around, right? So this is actually the common syntax, and the other one is only syntax sugar when something is simple. As with many things with Scala. Scala is a very consistent language, right? So if it's a one like teeny tiny expression, then you can leave the curly braces out. I mean, technically this is also an expression, right? But yeah, so for complicated things, you need the curly braces. The last two things that we have with strings is actually an example that I copy pasted from Wikipedia. Let me remove everything from here, and let me actually remove far away as well. So I'm just going to copy paste it. This format function that we were calling, it can actually format a bunch of different things, right? So this is a weird sentence right now, and let me actually show it to you, right? So what it's doing is it has a color, right? And then it says, okay, I'm going to give you a string, right? So we'll give it a string, and it doesn't do anything with it, right? Then we're going to say, okay, this is a number, and we have this D over here, right? Then we give it a number, and it stays exactly the same, right? But then we say, okay, this is a number, and then we have this more weird syntax, right? So what we're saying is, okay, so this is a number, in this case 89, but what you should do is you should take zeros, right? And you should pad them from the left until the number 89 is 5 characters long. So what we have is here 00089. If it's something else than a zero, right? If it's just a number here, right? So all of a sudden we say 15, right? So all of a sudden what's going to happen is that we have 15 characters over here, right? So we have the space, which is this one, right? And then we have the 89 was 15 characters, right? So it's probably 13 plus the 8 and the 9. Let me revert it to 0. Okay, this one is sort of simple. It just converts the number that you're giving it into hexadecimal, right? So 255 is actually FF. The last one that we have is a float. So we give it a floating point number, and we tell it, okay, first of all, it's going to be a floating point number, and we want to have 2 characters after the dot, right? So we have dot 1 4, and the whole thing should have 5 characters long, right? So we have a float over here, and there's a space, and there's 1 2 3 4 5, right? So again, if we do a 10 over here, for example, then it's going to be further. Let me revert it back to 5. So I showed you this just to show you another type of interpolation in Scala, and it's called F interpolation. So the other one was string interpolation with an S. This is also a string interpolation, but exactly for this format. So what I'm going to paste right now is exactly the same thing, just with a new syntax, right? So it looks exactly like string interpolation. So you just started with an F, right? And then you give it the patterns in exactly the same way, right? So this is the pattern, this is the pattern, this is the pattern. It's exactly the same patterns, right? You escape the actual number with $1, and then you give it the pattern. All right, we're sort of done with strings, and the next thing we're going to do is we're actually going to take some number from the terminal, from the user, and actually store it in a variable, right? So we're going to have a val x equals scala.io standard in read line, okay? And now we're just going to print out x. We're going to print out x plus 10, and we're going to print out x dot to int plus 10, right? So what we see here is now it's stopped, right? It stopped the current thread until we put something in, right? So let's put in a number. Let's say 15, right? So this is a 15. This is a 15 and 10 just concatenated together, right? Because x is a string, right? So this over here is a string, right? Don't forget, everything comes in as strings, right? So let's do 15 again, right? So it just attaches 10 to 15, and over here it actually converts it to an integer first, and then it adds the 10. Let's give it something else. Let's give it high. Then obviously it's going to explode, right? It's going to say number format exception. It didn't know how to format this as a number. It was actually flowing somewhere over here. We should see it actually. Yeah, here, line 9. It explodes over here, right? So if you already know that you want an integer, then you can just say read int, and obviously this is not going to work, right? And there's no point in converting it to int. It's just going to work, right? So if you're going to give it 15, let me scroll down. Yeah, so if we're going to give it 15, it's just going to know that its integer is going to add a 25. There's no need in printing it out, right? 15. All right. So if you're not using those, if you actually stick to read line, then you can actually give it an argument of a string. So it's going to be favorite number, and there's usually a colon and a space, right? So we're going to do, it's going to say, okay, what's your favorite number? I'm going to say, okay, it's 15. Well, then the result is 1510, right? We forgot to convert it to an integer, right? Right, so what's your favorite number? 15. 15 plus 10 is 25. Okay, one of the last things that we're going to do is function literals. So let's have two functions. We're going to have an f, right, which is going to take an integer and produce an integer, and it's just going to do, whatever we give it, it's just going to do plus 5. And now let's have a g, right, that is just going to divide by 2, right, divide by 2. So if you print out f or g, it's actually not that interesting, right? It's going to look weird. What we usually want to print is something like this. G20, right? And I know it looks simple, but I'm still going to do this. 15 plus 5 equals 20, and over here I'm going to be 20 divided by 2 equals 10. Okay, so let's have a print line over here. So let's say you want to combine them, right? And combining them is actually simple if you already know which arguments you're going to apply them to, right? So you can do f of g of 20, right, which is going to do 20 divided by 2 plus 5 equals 15, or the other way around, the g of f of 15, we're going to do 15 plus 5 divided by 2, and this is going to be 10, right? Okay, so we have 15 and a 10. Now, this looks like a combination of them, right? But we actually already have an argument. What if we don't have an argument, right? What if we just have this function, right? And then this function is coming from somewhere else, and all we want to do is we want to combine them and produce a new function, right? And then give it to somebody else, and somebody else is going to apply arguments to it. This last bit might be a little bit complicated, but it's actually not. So let's have a print line over here, right? So we're going to have we're going to define a helper function. We're going to say, okay, apply the right one first, and then apply the left one, right? So we're going to pass it the left one, which is a function that takes an integer, produces an integer, and the same thing for a right one. Just give me a right one, right? And what it's going to do, it's going to produce another function that takes an integer and produces an integer, right? So we have an equal sign over here, right? So we have some. So once you give us some input, what we're going to do is, as we said, we're going to apply the right one first to the input, right? And then we're going to apply whatever came out to the left one, right? So if we do val g then f, it's going to be right then left fg, right? And we're going to print it out. I'm going to print out, sorry. We're going to print out g then f, and we're going to give it a 20. Then it should be exactly this as this. Do g and then do f. So what should come out is 15, right? We see the 15 over here. And now we're going to have an analog to this one, right? So do the left one first, and then the right one. Okay, so we're going to do left then right. It's going to be left int right int. And same as above, right? Just the name is different so far, right? So now we're going to do input, and then we're going to do the left one first, and then whatever comes out, we're going to do the right one, right? So now what we're going to have is f then g equals left and right fg, right? So first f, then g, right? Print out f then g of 15, right? So it should be exactly the same. So 15, 10, 15, 10. Now, if you've never dealt with code like this, especially if you're coming from a different language, then it might look complicated, but in fact, it's actually not super complicated. And in fact, it's so common that it's actually built into the Scala library. So let's take this one, for example, right? Let's have a print line over here. Let's paste it in, right? So instead of doing this, okay, we're just going to do f compose g, right? And we're going to call it differently because it already exists, right? And let's do the same thing with that guy. Let's copy that, paste that. It's going to be g compose f, right? And again, it's going to be 2, right? It should be exactly the same thing, right? 15, 10, 15, 10, 15, 10. In fact, there is yet another one that looks pretty much like this. So let me also use the print line. So let me copy that, let me paste that. And it's called andThen, right? So if we do andThen over here, then we need to switch them, right? So do G, then F, to F, and then G, right? Exactly how they're called, right? But in this case, it's the third one. So it's a third one, it's the third one, it's the third one, right? And what should come out is exactly the same thing. Let me maximize Sublime real quick so that you see the whole example. Let me actually make it a little bit smaller. Maybe it's a lot smaller, right? But I want you to see the whole example, right? So we have basically four ways of composing functions. We do this manually. We have our own helper functions, right? Or we use compose, or we use andThen. So I highly advise you to start with compose, because in my experience it has a better type inference than andThen. Okay, but they're literally the same. All right, we're almost done. Actually, let me increase it again. Let me remove everything. And we're going to say a few, we're going to mention a few things about equality. So we have this function, and we have this function, which is exactly the same one. That's what it seems, right? It's just that one is called f, and the other one is called x. So even though, actually, let me minimize Sublime again. So even though f is the same as f, right? All of a sudden, f is not the same as x. Now, Scala doesn't really know that they're the same, but somehow, in this case, it does. And what it's doing is it just compares the references. It sees, okay, it's referring to exactly the same thing, right? So if what we did was over here, if we actually used f, then all of a sudden f will be the same as x, right? So this is where the references are compared. This is just one thing to know. Like, equality in general is a very big topic in programming, and we're going to talk about it very, very often, and yeah, quite a lot actually. If you're coming from a different language, specifically Java, then you should know that in Scala, equals, it actually just delegates to this, right? Hold up. So equals actually in the Scala library, it just calls the method called equals. It's just that unfortunately in this case, what equals is doing is just comparing the references. So if you just want to compare the references, then Scala has it built in. So what it's called EQ. For, hey, other references the same, and you also have an E for other references not the same. In this case, it doesn't actually really matter, and we're going to talk about equality we're going to talk about equality actually quite a lot. Okay, all right, we're done with this video. I'm gonna see after editing how long it actually got. If it's slightly longer than an hour, I'm actually gonna leave it as one video. But we're actually done. Before I leave, I'm gonna leave you with a smiley, right? So we also forgot to talk about unit. So a unit, is it equal to unit? And we're gonna do it like this as well, right? And we're gonna do this one like that, and we're also gonna do that one. All the possible ways to write unit. So you get a bunch of warnings. They're all true. There's only one instance of unit. It's always the same to each other. Comparing values of type unit and unit string will always yield true. All right, I hope you liked this video. Let me know what I can do better in the comments below. Subscribe to this channel if you're new here. There's going to be a lot of Scala related content and in general content related to programming. And yeah, take care.